Hi guys, so here in this session we are going to discuss about one of the very important concept of combination of stack and queue. So this is a very important and interesting topic friends. So you may get questions in competitive exams, that is how many number of queues are needed for constructing a stack or how many number of stack is needed to construct a queue. So it is a very basic and very important questions. So I just want to explain you how it is being done. So see, this is the main 2 points which I have written here. So you please make a point, right? So if I want to implement one queue, I need two stacks. Okay, if I want to implement one queue data structure, I need two stacks. Or if I want to implement one stack data structure, how many number of queues is needed? It is two queues. Okay, so this is a very important point. So please make a note of it. They may ask questions in MCQ format, right? So now I will take any one example and I will explain you how it is possible. Okay, so now this is a queue data structure. So what is this? So this is a queue data structure. So by using this queue data structure, I will show you how one queue is built by using two stacks. Okay, so that we are going to discuss it. So these are all the list of elements that I am going to add it inside the queue data structure. So now I will tell you what is a queue and what is a stack data structure. Suppose if any viewers who didn't watch my previous videos of stack and queue, so please watch it and then come over here so that you will be able to understand friends, right? So what is a queue? A queue is going to have two pointers, front and rear pointers. So what is a stack data structure? Or stack is also will be having only one pointer. So by using only one pointer, I am going to extract the topmost element. But in queue, front pointer is used for deleting or getting the element from the queue data structure, and rear pointer is used for inserting the element at the last. Okay, so all these things we have discussed, isn't it? So based on that rules we are going to implement here. So now these are all the list of elements. So what is the first element? So the first element is A. You please insert this. So now front is pointing here and rear is pointing here. Okay, I have inserted A. See, front and rear are pointing to the same location. So now by incrementing the rear pointer, I will be inserting the remaining elements. So the remaining element is B. Right? So B is inserted. The next I will increment the rear pointer and C will be inserted. Then D and then E. So rear is pointing here and front is pointing to this location. So now we will just display and see. So what will be the output of this queue data structure? So how the element will be extracted? So the element that is pointed to by the front pointer will be extracted, isn't it? So now this is my front element. So A will be removed. So A is the output, and then B, right? And then C. Like this it will be removed. Then D and then E. So this is my final output. So now I want to get the same output by using the stack data structure. How can I do? So now you see. So let me erase this. Now I am going to draw a stack data structure for getting the same output. Okay. So now let me draw a stack data structure. So this is a stack data structure. So let me insert one element as it is. So first, so what pointer I am using? I am using the top pointer. So I will be incrementing the top pointer one by one and I will be inserting the element. So A will be inserted, right? So top will be incremented. So B will be inserted, then C will be inserted, then D, right? And finally E will be inserted. So like this the element will be inserted. So now this is the topmost pointer. So in Q, what was the output? A, B, C, D and E, isn't it? So by stack, if I want to get the output, how my output will be? So first E will be printed, isn't it? E will be printed, then top will be decremented here, right? So D will be printed, then here it will be pointing, C will be printed, and then B and then A. Okay, so like this only you will be getting the output. You will see whether the output is matching. No, it is not matching. So, in order to get the same output, I must have to implement another one stack. So, that is stack 1. So, let me draw here. Okay, so let it be S1 and S2. So, from S1, I have retrieved all the elements and I got this output. Isn't it? So now, in order to get the same output, what I must have to do is, once each and every time when I retrieve the element from the stack 1, I must have to insert instantly into the stack 2. Simultaneously, I must have to insert that element. So what was the first element in retrieve? So it was the first one and second one and third one and fourth one and fifth one. So this was the order of the element retrieval from this stack 1. So now I want to push this back into stack 2. Okay, so after deleting this element, I must have to push back. So for your understanding, let me once again draw this. Initially the data structure was like this, isn't it? A, B, C, D and E. While getting the output was not in match. So it was E, D, C, B and A. Okay. So in order to get the same output, once again I want to delete and reinsert into the stack 2. So delete this element E. So insert here. Right. So this is top pointer. So again delete this element. So D. Right. Then once again delete this element C. Right. Then once again delete this element C, D, C, B and then finally you will be getting it as A. Okay, so these are all the set of elements once again inserted into the stack 2. So now you delete the elements from the stack 2. So now you check what will be the output. So this is the output of stack 1, this is the output of Q and this is going to be your output of stack 2. So now you check what is the topmost element. So A will be retrieved, isn't it? So A will be removed. Then once again top will be decremented, right? So B will be removed, isn't it? Then C will be removed, right? C is going to get come out. Then finally D, then E. So now you check the output of the 3. So which is same? The output of Q and the output of stack 2 is same. So in order to get the output of the same one as that of Q data structure, I want to implement 2 stack. Okay, so like this you can also prove for this condition, 2 Qs and 1 stack. You just try it and give me the answer in the comment section. So I think so now you will not able to forget this type of the points, that is this type of the important hints. So please make a note of it so that you will be able to remember lifelong. Right friends? So in the next session, we are going to start up with another interesting and very important topic of data structure. So bye.